Welcome to this Optomec AJ200 training video. This video is going to serve as a brief overview of the AJ200 printer, its features and capabilities. So this system has four main components to it: the system computer, the process control electronics, the print systems, which include both the ultrasonic atomizer and the pneumatic atomizers, as well as the motion and vision systems. So the process control electronics consist of the system computer, which you see on the screen now, as well as the electronics rack. So the top part of the electronics rack is the system computer tower. Underneath you have the Kiwa interface module, Kiwa being the software that we use for interfacing with the printer. So we have the KIM distribution model and the KIM panel. The KIM distribution model has the process controls, such as the process camera, lighting, and the alignment camera lighting. It also has the ultrasonic atomizer power. So we also have the emergency override button there, as well as the reset button. The bottom part of the panel, we have different power controls, such as the heating controls and the overall power. The back of the electronics rack also contains the system control plate, which contains the mass flow controllers, or MFCs. So the MFCs are the controllers that control all the gas flows going to the system. So these are found at the back. So the AJ200 system contains two printing systems, one being the ultrasonic atomizer and the other being the pneumatic atomizer. So the ink flow path for the ultrasonic atomizer, the reservoir is in here. The ink comes through the tube, through this assembly, all the way down to the nozzle. The nozzle will be shown later, and it comes out the tip. The pneumatic atomizer, the reservoir is here. The gas comes through all the way through here. It also has an additional exhaust line, which is here. And if we were wanting to switch between the ultrasonic atomizer and the pneumatic atomizers, the ink would be coming through there and into the tube as well. So this is the nozzle of the system, or the tip as well as it's called. So the ink, as shown previously, comes through this tube here, this plastic tube, where my finger is here, comes down through, goes into the tip, the deposition head we call this here, through into the tip. So this system has a mechanical shutter you can see on the other side. It's just used to interrupt the flow of ink. So both the pneumatic and ultrasonic atomizers use a sheath gas, which actually comes through on this side. So the sheath gas comes through and it's just used to focus the beam, as well as coat the insides of the deposition head to ensure there's no clogs. Okay, so the main difference between the ultrasonic atomizer and the pneumatic atomizer is the method of atomization. So the ultrasonic atomizer, as before, it's found here. So what it uses is an ultrasonic transducer to create pressure waves that will shear off ink mist off of the ink, which is found in here. So this is the reservoir. Additionally, since the ultrasonic transducer runs a lot of current through it, we always have to run it under water cooling. So we do have a bath that is switched on with this feature here, and you should be able to see the water running through it. So we can also edit the temperature of the water, so we can cool the ink at a certain temperature. And this is found in the chiller, which is seen in this next little pop-up clip. So that's the ultrasonic atomizer and transducer. So I'm going to turn off this. Now the pneumatic atomizer, as shown before, the reservoir is in here. What it uses is a high pressure gas stream to shear off particles off the ink. At the same time though, we cannot use all that gas to go through the nozzle, so we also have an exhaust and a virtual impactor. So because of the difference in atomization, the pneumatic atomizer is most suited to inks with viscosities between 1 and 1,000 centipoise, whereas the ultrasonic atomizer is used for more thin inks between 1 and 10 centipoise. So once again, these are the nozzles, or this is where the nozzle usually sits. For this system, we have a fine feature head and a wide feature head. So the fine feature head, which is found on the system right now, the tips range with an inner diameter of 100 micron to 300 micron. And the wide feature heads range all the way up to 3 millimeters. So the AJ200 features a heated platen with a vacuum exhaust on it. So a vacuum exhaust would generally be found underneath the system, so that would have to be manually switched on. So in addition to the platen and the exhaust, we also have two cameras. There's an alignment camera and a process camera. So the process camera, this actually unscrews here, and it swings wide. So this process camera moves inwards this way, and it actually images the deposition. So it's just a little bit easier to see where you're actually printing with this camera. The second camera is called the alignment camera, and it is found right here. So you can see the light from the alignment camera hitting here. So there's a bit of an offset between the process camera and the alignment camera, but the alignment camera is just used to actually align with the features of the printed substrate.